We are moving from solving absolute value equations to solving absolute value inequalities. And so let's just take a second to review what that even means. So inequalities, by the definition of the word, are things that are not equal. And so this is where we use our symbols like less than or equal to, greater than, or equal to. So we'll be looking at how we solve inequalities involving absolute value and also sketch them on a number line, because number lines really allow us to visualize and see what's happening. So let's start off simple. We're going to solve and draw on a number line. The absolute value of x is less than 3. We're going to start with the number line so we can think about what this looks like. Let's first talk about the meaning. Absolute value means distance from 0. So if I sketch a number line, and I think about where 0 is, I put it in the middle, here's 0. This is saying the value of my number, right? My value that I'm working with, the number, the solution to this has to be less than 3 places from 0. That's what this means. So if we look at where that is, well, 3 places from 0 starts at 0 and goes up 3. So it goes 3 this direction, which takes us to the number positive 3. But it also goes 3 places back this way to the left, which takes us to negative 3. So really, if I'm looking at what numbers could make this statement true, right? This original statement, the absolute value of x is less than 3. It's really anything in here. It's got to be something that's bigger than negative 3, but it's got to be something that's less than 3. So anything in this area, shaded from negative 3 to 3 with open circles on 3 and negative 3. And so, kind of like we did with equations, you can split this up and say x would be less than 3, but x would be, so we take this and we put it here, and we also put it here. X is going to be, we flip it around. We change the inequality, greater than negative 3. So notice how these two statements, here and here, fit with this graph. X is less than 3, so that's starting here and going that way. X is greater than negative 3. That's starting at negative 3 and going this way. So it's where those two arrows overlap each other. And whenever we have an absolute value that overlaps like this, and whenever we have an inequality that overlaps, and when we're working with absolute values that are less than, we look at these using the word and. This and this both have to be true. X has to be less than 3, and x also has to be greater than negative 3. Any number that we pick has to make both of those statements true. We often combine them into an compound inequality that looks like this. X is less than 3, and x is greater than negative 3. Notice how I wrote this working backwards. So we can put it into one big statement if we want to. That's what this means if we want to condense it. X has to be less than 3, so these numbers going this way, but greater than negative 3 going that way. Okay? So let's solve one that has a little more going on. Let's solve this. The absolute value of 4y minus 6 is less than or equal to 14. So we're going to solve, and we're going to graph on a number line. So we'll do that for all of these, just so we can have that practice. Now, if you want to pause the video and try this based on what you think you might do, give it a shot and then see if it matches what I actually do. Okay, so when I look at this, I notice that the absolute value is all alone on the left side of the inequality. There's nothing else outside of my absolute value. Once we get that, we can take the expression that's on the inside and we can break it up into two statements. 4y minus 6 is less than or equal to 14, just like we have there. And then we also make a second statement. 4y minus 6 is greater than or equal to, so we flip it around, negative 14. Both of those statements have to be true. Let's solve them both. So if we add 6 to both sides, we get 4y is less than or equal to 20. And then y is less than or equal to, if we divide it by 4, 5. Over here, if we add 6 to both sides, we get 4y is greater than or equal to negative 8. And dividing by 4 gives us y is greater than or equal to negative 2. So what word do we put in between these two things? That's right. And y has to be less than or equal to 5, and y has to be greater than or equal to negative 2. And so what does a number line look like? Well, let's draw one, and let's put these two numbers on there. So I'm just going to say negative 2 is here, 5 is up here. If you like to put 0 just to give yourself a starting point, that can help. And I know that I'm going to be shading less than or equal to 5. So when it's equal to, when it's got that extra little line, we know we draw our circle, but we shade it in, which means 5 would also be a solution. And we're going to start shading to the left this way. I'll keep going later. This one, y is greater than or equal to negative 2, starts at negative 2, again with a shaded circle, and then that's going greater than. So it's going to be going to the right. So notice how it meets up with this one, right? So it's everything between these two numbers. Now, a nice way for you to check your answers. I know a lot of you like to check to make sure I did things right. When you make an inequality with a graph like this, it splits the number line into 3 separate areas. You've got a section over here, a section up here, and then you've got this section that you shaded. Try picking any random number from all 3 of those sections. Anything you pick down here should not make this a true statement. Anything you pick up here that's bigger than 5 also won't make it a true statement. But if you pick a number between negative 2 and 5, it will make it a true statement. So pick 3 random numbers. Let's say you could pick, I don't know, negative 10 and 1 and 8, right? Those are numbers that fit into these 3 sections. Take those 3 numbers, substitute them into this big statement that we started with, in for your y, work the problem out 3 times. Negative 10 should give you a false statement, 1 should give you a true statement, and 8 should give you a false statement. That's just a way to check, right? To make sure that you've done it properly. Okay, so let's do some more here. Let's go with same thing, solve and sketch on a number line. Let's do the absolute value of x is greater than. So I'm going to now do some greater thans. Absolute value of x is greater than. Let's use that same number we started with, 3. Just pause this and see if you can sketch what you think this should look like on a number line. Okay, sketch out what the number line of this would look like. Where would our solutions be? What numbers would make this a true statement? Where would they exist? I'll keep going. Here's 0. What this means is all of our values of x, any number that we put in for x, because it's an absolute value, has to be more than, greater than 3 places from 0. So if we look at our number line and say, all right, well, here's 3 places from 0, right? That's 3 places from 0. All of our numbers, all of our answers, all of our solutions have to be more than 3 away from 0. I'm going to put an open circle here, and I'm going to be looking at these numbers that are up here, right? that go all the way up to infinity, right? So starting at 3, not including it, but everything bigger than 3 would be more than 3 places from 0. We also have to go in the other direction too. So if I look to the left and I go to -3, I don't include -3, but I look at everything that's past it on the number line to the left, all these numbers, all the way down to -infinity. So all of these numbers to the left and all of these numbers way up to the right should make this a true statement. Again, let's pick some numbers and test it out. Something down here, -10. What's the absolute value of -10? Is that greater than 3? Yeah, the absolute value of -10 is +10. And yes, that is greater than 3. So that checks out. That makes it true. What about something up here? Let's pick a really big number like 100. So same thing. What's the absolute value of 100? Is it greater than 3? Yeah. It's just 100. And yes, 100 is greater than 3. So this checks out. All of these numbers will work. Let's look at a number here in the middle of this stuff that's not shaded. Let me pick, I don't know, -1, right? -1 would be about right there. What happens if we plug that into this inequality? The absolute value of 1 is greater than 3. Is that true? Well, the absolute value of -1 is +1. Is that greater than 3? No, it is absolutely not. No, that's not true. So this does not work, and it shouldn't work. We didn't shade it, so it shouldn't work. We're looking for the numbers that make it true. So how can we write this? Well, let me bring this back over here. I'm going to rewrite my original inequality. The absolute value of x is greater than 3. We can split it up into 2 statements again. Take the thing on the inside and just rewrite it without the absolute value bars. X is greater than 3. And like we did before, x is, flip it around, less than, and then the opposite, -3. Now, there's an important word that goes between these 2 statements, but it's not the word and. It's going to be the word or. Why? Because these 2 shaded areas are separate from each other. They don't overlap. Our solutions can come from down here, or they can come from up there. We only have to find a single number that makes one of those true. So we say x is greater than 3 or x is less than -3. Our solutions only have to make one of those statements true. All right. So whenever we have an absolute value that's greater than, we use the word or to show our solution sets. Okay, let's look at a couple more here. Let's do the absolute value of 6m plus 3 minus 2 is greater than or equal to 13. So this incorporates the absolute value as part of our inequality statement. But you'll also notice there's something else that's hanging out outside of that outside of that absolute value. So do you know what to do here? Pause and see if you can try this, and then I'm just going to keep going. Before we can separate into 2 separate inequality statements, before we do that, we first have to get rid of anything else that's over there with the absolute value. We can't have any other things over here except the absolute value. So we have to get rid of that -2 by adding it. Let's add 2 to both sides. That leaves us with the absolute value of 6m plus 3 is greater than or equal to, because this thing is gone, 15. Okay, now let's examine it. Our absolute value is all by itself. So we are okay now to separate it. Take this, write it as 6m plus 3 is greater than or equal to 15, just like this. And then over here, 6m plus 3 is less than, remember, we flipped the direction, less than or equal to, and we make it -15. And we solve both of these inequalities. Minus 3 from both sides gives us 6m is greater than or equal to 12. Divide by 6, m is greater than or equal to 2. Over here, subtract 3 from both sides. 6m is less than or equal to negative 18. Divide by 6, m is less than or equal to negative 3. It's greater than, so are we using and, or are we using or? Maybe you're not sure, so that's where the graph can help us. Let's find what these two look like on the graph. M is greater than or equal to 2. So if here's 0, here's 2, I would make a shaded in circle right above 2, right on the number line, and shade to the greater than side, so to the right. I'm shading up here, okay? And if I look at m is less than or equal to negative 3, I'm going to put negative 3 down here, and I'm going to make a circle on negative 3, shade it in because of the less equal to bar, and shade to the left. So when they don't overlap each other, the word we use there is or. M has to be greater than or equal to 2, or it has to be less than or equal to negative 3. Any numbers I choose from this section or this section will make this original statement true. Anything that happened in between those two numbers will not make it true. All right, one more. So this one looks like this. 2 times the absolute value of x plus 4 plus 8 is less than or equal to 6. So solve this. And I'm going to give you a minute to, well, I'm not going to give you a minute. You're going to pause. You're going to try this on your own. And I'm going to keep working. But pause it, see if you can work through this. So just like before, we've got some other stuff that's over here on the left side. We got this 2, which is being multiplied by our absolute value. And we have this plus a. We need to get rid of both of those things. First, we always get rid of the extra term. So we're going to subtract 8 from both sides. That leaves us with 2 times the absolute value of x plus 4. This is gone. So it's going to be less than or equal to negative 2. Then we'll get rid of the 2 that's out front here. Because it's times, we'll divide both sides by 2, leaving us with the absolute value of x plus 4, these canceled out, is less than or equal to negative 1. All right? Now, here, hopefully something jumped out to you. Do you remember that absolute values can never give a negative answer? Whenever you take the absolute value of something, it has to have a positive value. Take a look at what we have right here. The absolute value of x plus 4 is less than or equal to negative 1. Less than or equal to negative 1 means I'm only going to have a negative number as an answer. And based on what we know about absolute values, that's impossible. If we have less than or equal to a negative number, there's no way that can happen. So we say that this one has no solution. Now, if you missed that when you were working it out, there's still a way for you to catch it. Here's how. Do the same thing we've done before. Take your x plus 4, write it as x plus 4 is less than or equal to negative 1, and take your x plus 4 and write it as greater than or equal to positive 1, right? Flip this stuff around. And if you solve both of those, you get x is less than or equal to minus 4 from both sides. That's less than or equal to negative 5. And if we subtract 4 from both sides here, we get x is greater than or equal to negative 3. Whenever we are doing less thans, it's and. Okay, it's got to be and. They both have to be true. So that's where our graphs are going to overlap. If you try to graph these, here's 0, here's negative 5, here's negative 3. X is less than or equal to negative 5 is shaded here. Greater than or equal to negative 3 is shaded here. Because this was less than, which means it's and, this has to be where those two lines overlap, and they don't actually overlap anywhere, which means there are no numbers that make both of those true. Another way to see that it is no solution. And that is it for solving inequalities with absolute values.